So this is part 3 of using addition rules for probability. And in the previous 2, we were given counts. And so technically, we didn't have to use the 2 addition rules. We could just look at the Venn diagram and count things, but we did use the addition rules and then we checked them by counting. But here, we're not given counts. We're only given probabilities. So that's all we have to work with. So let's start by writing in the probability of example number 3. So example number 3 says, suppose that the probability of A equals 0.65, the probability of B equals 0.21, and the probability of A and B equals 0.13. Find the probability of A or B. All right, so A, the probability of A equals 0.065. So remember, that's the whole circle. And that's going to include the middle here, which is going to be, I'm going to write it really small here. Well, I guess it's not really small, but that's the intersection, A and B, 0.13. And then the probability of B equals the 0.21. And remember, that's this whole circle. So they're sharing that 0.31. That's the intersection. Okay, so if you don't know the formula for or, so here we have we're going to use one of the addition rules because it's asking for the probability of A or B. And this one is not mutually exclusive. So not mutually exclusive. I could have read that in purple, I guess. Not mutually exclusive. So we need to use the one where we subtract away the intersection so that we don't double count it. So A and B. All right, so for this one, we're going to have the probability of A is 0.65 plus the probability of B is 0.21 minus the probability of both of them is 0.3. And so I get 86, I get 73.3, right? Yeah, okay. So the probability of A or B for this one is 0.73. So that's everything that's in one circle or the other. Right, so this is what we're looking for, everything here. All right, so for the next example, 4, suppose that the probability of A is 0.37, the probability of B is 0.5, and that A and B are mutually exclusive. Find the probability of A or B. So we are told that they are A and B are mutually exclusive. So that means that there's nothing in the intersection. So the probability of being in the intersection is 0 because there's nothing there. And so A, the probability of A, which is the whole circle, but the intersection has nothing in it. So the probability of A is 0.37. And the probability of B is 0.5. So we have the probability of B. We're going to be adding to the probability of A, which is 0.37. And this is 0.5. and we're adding these together. And we get 0.87. So the whole in one circle or the other is 0.87 for both of them. And those are the two addition rules for probability. So when we're looking for the probability of an event A or an event B, regardless of what A and B are, it's an or situation, then we can add them together. But if we have something in the intersection, so if we have something in the intersection right here, then we have to subtract the intersection so that we're not double counting it in both A and B. And that's it.